I'm going to talk to you about some 3D printing options because when this whole thing began and there was major shortages of PPE, makers, a lot of makers stepped in and used 3D printing, used other materials to try and create respirators for the first line workers in hospitals and medical centers. And while their efforts were valiant and I think they made a difference, we have to be careful because a lot of these creations can look fantastic, but they may not necessarily be effective. And we don't want doctors walking into a room with potentially infected people thinking they're safe when they're not actually safe. So what my goal was, it was twofold. I wanted to look at improving the fit of fabric face masks so that we can make sure that not as many particles are leaving the face mask. That shouldn't be. And the other one was to look at 3D printed respirators and to check their efficiency and make sure they're fitting properly, because fit is extremely important, as well as make sure that the people wearing them can actually breathe. So I had this kind of twofold goal, and it complemented what Rita's doing, because Rita's looking at the efficiency of fabrics to filtrate or filter particles, as well as creating a good fit without necessarily needing a frame around the mask. So our two projects complement each other quite nicely. So let's look at the mask frames. Anybody who hasn't 3D printed probably doesn't appreciate how long 3D printing takes. It is an extremely slow process. It's much faster than the old process where you had to send a model to a company who would then create a prototype for you and then would send it back to you, which could take weeks and weeks. So it's definitely faster than that, but it is also a very slow process. For instance, creating a frame like the one you see on the screen right here can take anywhere from 20 minutes to half an hour, which doesn't sound long. But creating something a little more substantial like a respirator can take up to 12 hours to print. So the first frame that I looked at was a flat frame. And the reason for that is that it's the fastest to print. Anything that's going to be flat on the printer bed is going to be faster because it won't require supports. Now, I kind of knew when venturing into this that a flat frame is going to be a bit of an issue because our faces aren't flat. And, oh yeah, I had a whole slide for that already. And you can see that in this image here. The problem is our faces aren't flat. So can you see my mouse cursor? Can somebody say audibly? Yeah, okay, thank you.
Yes, we can.
So we can see here that there are gaps there, and there are going to be gaps. I mean, unless you have a very chubby face, there are going to be gaps in various places because our faces aren't flat. The other problem with a frame like this is that it comes under your chin. And the moment you try to talk or you move your jaw in any way, it pulls the whole frame down, which then starts cutting into the top of your nose. But because science is science, we decided we had to print one anyway, just to prove that our ideas were on par. And we did find that there were problems. You can see here that the original design on the left, especially on my face, created significant gaps at the bottom on the two sides of my jaw. So I altered it slightly to try and make it a little more contoured to my face, but there were still gaps at the bottom of the jaw. And so I altered it again and it fit my face better. But I have to say the problem is that even though it in a static position, it fit my face better, it was still cutting into my nose anytime I tried to talk, which was obviously problematic. So then we thought, okay, well, we'll go into 3D frames. These are going to fit our faces better because they are, they're a 3D shape, which our face is. And what's nice about these, especially if you have an inside frame, you can use a flat piece of fabric. You don't actually need to use a mask that's already made because you can just lay it over the frame, put the outside part of the frame on, and then off you go. The problem is the print is much longer. To create a frame like the bottom part here, This is about a 5 or 6 hour print because of the supports. And the other problem is you still need to adjust it to a person's face. Adjusting something flat like this without 3D modeling skills is relatively easy. Adjusting something like this without 3D modeling skills is much harder. So this is definitely a disadvantage, but we needed to try it out. So we did try it out. So I'm going back and forth between my slides here. So we did try it out. The problem is that the original design was enormous. And by the time I shrank it down to fit my face, each individual element was so thin that the frame would snap. I mean, with just any movement, the frame would snap. And this is a major problem because a lot of these masks, the people who design these frames and respirators and such, are male, and they're white males, and they have very large faces, and they're designing it for the size of their face, which makes sense. I mean, nobody's going to blame them for that. But by the time you scale it down to fit my face, for instance, these individual parts become so fragile that they end up snapping quite easily. It was also extremely uncomfortable. As you can see in this image at the bottom right here, this part of the frame is against your face. And PLA, it's a hard plastic. So it's extremely uncomfortable. I mean, that hard plastic is directly against your face. If we were to wear something like this, we would have to make sure that there was a fabric border between the mask and the face so that it didn't hurt as much. This is just to demonstrate. You can see on the right here, I'm printing the part here that's in aqua, this frame. All of this under here is support. All of this gets broken off, but it needs to be printed nonetheless, which is why it makes that kind of print so long. Thankfully, we came across a frame that worked in both ways. You print it flat, so it's very quick. Then what you do is you heat it up and you mold it to your face. What's great about this is that it prints quickly because it's flat, but also you're molding it to your face. You don't, it's going to fit you because you're molding it over the mask to your face, and B, you don't need those 3D modeling skills to be able to adjust it to you. So this design was great, and when we discovered this, we decided to run with it, and we ran some tests, and what these results show you is we had 4 different types of masks. We had 2 surgical type masks that have the pleats on the side, you know, the typical square surgical masks that you see. And then we had a mask that I had created to test. It's kind of a hybrid between the fitted masks that you see commonly, and it looks like an N95 mask a little bit, but it's made from fabric. So we tested with that, and then we tested a third one that was a fabric mask, but not made of surgical mask material. And as you can see here, apart from this mask in purple, which the frame did not help at all for some reason, for all the other masks, if we look at this one, when we put the frame on, the amount of particles that would pass through was quite significantly reduced. Okay, so in the green here, this is that particular mask without the frame. This is that particular mask with the frame. Now remember, lower scores are better because this is how many particles are able to penetrate through the material, through the mask. Okay, not the material, but through the mask overall. Okay, so apart from this one, and we think that the reason why it didn't really help this one was because that mask was made from quite a thick material that had pleats in it. And so the pleats probably resulted in some gaps on the side, which is why even with the frame, it didn't help because it was just bunching and folding under the frame. So that's where we are currently with the frames. So the frames seem to be quite effective. So now turning to respirators. Again, you know, just getting back to reviewing quickly, with the mask, we were looking at improving the fit with around the face. With the respirator, we need to improve the fit, but we also need to think now of pressure drop. Okay. So the first, ones that we looked at were the very popular, common, prototypical masks, respirators that were, put on websites like Thingiverse, and, they all advertised them as like small and compact and fast to print, and these are going to be great. Yeah. The problem with these masks that's immediately evident is that they have very, very small areas where air can pass through. So these masks result in a drastic pressure drop, which means that people can't inhale enough air to be able to breathe comfortably. But, you know, again, in the name of science, we had to try it out just to confirm this. So evidently, I haven't even tested it on the apparatus yet. That's to come. But even just subjectively putting it on, I couldn't even take 2 or 3 breaths in that mask. I couldn't even inhale the air at all. The other problem was with little masks like this is that the edge of the mask is very, very thin. So as you can see, it just digs into my face. Even after 30 seconds of having that on to take the photograph, I took it off and I just had a red mark all the way around my face. It's extremely uncomfortable. But regardless of the discomfort, the front of the mask is, the opening is too small anyway, so it's just not going to work. So we looked at another design, and this design tries to solve both problems. What it does is you can see that there are the 2 parts. There's the orange part and there's the blue part. The orange part is printed in standard PLA, so it's a hard plastic. It's rigid, it's completely rigid. The blue part is printed in TPU, and it is a flexible material. And I'm just going to stop screen sharing for a second so that I can show you TPU. TPU, when printed very thinly, is a very flexible material. PLA, when printed thinly, is not. It's got some flex to it, but it will snap at a certain point. Whereas TPU, I mean, it can bend in half, no problem. And you can see on a mask like this is the actual mask, there is some bend to it. The problem is that even though there is that bend to it, in order for the mask to have some strength, it has to have some thickness to it. And that thickness, unfortunately, renders the material stiffer than our faces. Okay, so even though it is an improvement, it's still very stiff and it's still quite painful to wear for a long period of time. I still have yet to test whether this opening is large enough not to result in a pressure drop that's significant enough to be uncomfortable. So that test is still to be done. But those are all going to be done because obviously being on campus and all of this needs to be as restricted as possible. We're planning on kind of doing blitz testing in a couple of weeks. The other problem is that TPU is extremely finicky to use. It clogs printers easily. It has to be printed extremely slowly, about 10 times more slowly than PLA. So a mask like this will take about 12 hours to print if it prints properly the first time. So it's very finicky to work with. And I think for the benefits, the improvement it gives, the resulting comfort is, the benefits that it gives and the comfort that it gives, the time that it takes and the battles that you have to have trying to print the stuff makes it kind of not really worth it. Another option is using silicone. So this design, what they do is you print the frame of the respirator with PLA, the hard plastic. But then what you do is there's a mold that you put silicone in, skin-friendly silicone in, and then you put the mask onto it so that you have a soft surface that's actually touching your skin. Now, the problem with this particular design is that it's a little difficult to ensure the seal because the surface of the respirator that is actually touching the silicone is quite thin. It's quite small. And it has to be that way because if it were any bigger, then it would be digging into your face. So we're looking at now an improved version where there's not as much of the respirator is actually printed in hard PLA, and more of it is actually molded in silicone. And the advantage with this is that it actually stretches a bit. So when you're talking, it can stretch to expand a little bit and it's much softer against the face. Now, as I said, the opening at the front here we haven't tested yet if that will be effective in terms of not creating too much of a pressure drop for the person wearing the mask. That still needs to be tested. A possible future direction is to look at models that have more than one opening, kind of like, you know, the masks that you see, the respirators that you see in workshops. So the idea here is to create more openings so that there, again, won't be as much pressure drop, but we'll look into these options if this model results in too much of a pressure drop. Hopefully it won't, because the front is actually quite large. So that's basically where we are at the moment with the frames and the 3D printed respirators. The things that we found that we absolutely have to take into consideration is fit around the face in both cases for the frames and the respirator. It needs to create a good seal, but it needs to allow for jaw movement. So it needs to be flexible enough to allow for jaw movement, and it needs to be comfortable. If it's not comfortable, even if it's effective, people aren't going to be able to wear it for a long period of time. It also needs to be breathable. If there's too much of a pressure drop and people can't breathe and get enough oxygen, again, it's not going to be a viable option. And of course, finally, practicality. If, you know, makers or people who have 3D printers at home or want to access a 3D printer at the library, if they have to have the 3D modeling skills to make the adjustments to fit their face, if the materials aren't easily usable, then they're not going to be able to do it themselves. So this kind of option, these kinds of options then would be off the table. So we need to consider these factors in order to come up with good designs that people are going to be able to make themselves.